In this video, we will see what is acceleration. The definition of acceleration will be the rate of change of velocity of an object with respect to time. We already know what is velocity. Velocity is the rate of change of position with respect to time. So, for better understanding, we will see how to calculate velocity and then we will move into acceleration. For example, if you take this path and it's marked, the distance has been marked, and if a body takes 2 seconds to travel 10 meters of distance, and again it will take another 2 seconds to travel till 20 meters distance. Here, how can we find velocity? We already know the formula for velocity: displacement by time, and the units are meters per second. So here the distance is the distance or displacement. Displacement is nothing but distance with direction. So distance is 10 meters by 2 seconds, it is 5 meters per second. And if you calculate velocity between these 2 points, then it is again 10 meters distance has been traveled in 2 seconds. So again it will be 5 meters, and it will be same for this. So what we can observe here, the velocity is constant. Velocity is not changing. Okay, so the velocity is constant. So how, this is how we can calculate velocity. So now if I ask you whether there is acceleration in this case, means, see here, the rate of change of velocities, acceleration is rate of change of velocities, there is no change in velocity here. So here there is no acceleration. There is no acceleration. Okay, now let's say, for example, if a car is traveling at 80 kilometers per hour, constant speed in straight lane, will there be acceleration here? See here, acceleration is change in velocity. Velocity means, we know velocity is nothing but speed with direction. Velocity is a vector quantity, and the magnitude is speed. Magnitude for speed and velocity is same. The simple difference is, in velocity we will have direction. So here we can say velocity means speed with direction. So here it is given as straight line. That means there is no scope for direction, and the speed should be changed. So there is a constant speed of 80 kilometers per hour. So here there is no change in speed or direction. That means there is no acceleration here. For example, if I ask you, a body is traveling in a circular path, okay, at a constant speed of 30 kilometers per hour, constant speed. Here, will there be acceleration in this case? See here also, in the like previous case, the speed is constant. But what about direction? Because for acceleration, there should be change in velocity. That means speed and direction, we have to consider both. Here, for example, if you take body at this point, it is traveling, and this, if you take this point, it is traveling in this direction. If it is traveling in a clockwise direction, then it is traveling in this direction. If you take the direction of the body at this point, it is traveling in this direction. That means direction is changing. No constant direction. You can say no constant direction. So if there is no constant direction, obviously there is a change in velocity. If there is a change in velocity, acceleration exists. So this is how acceleration can be determined, whether it is present in any case or not. First of all, we have to see whether there is a change in speed, and then if there is a change in direction. Okay, now we will see the formula for acceleration, how we can calculate acceleration. First of all, another important point we have to remember is acceleration is not equal to high speed. If you are traveling at 150 kilometers per hour, that doesn't mean there is a acceleration, because if it is constant speed, then even not 150, 1000 kilometers per hour doesn't matter. If there is constant speed and there is no change in direction, then the acceleration is zero. Okay, so acceleration, sorry, not equal to high speed. Okay, here how can we calculate acceleration? It is v minus u by 2. This is the formula for acceleration. Okay, here a is equal to acceleration. Okay, in this formula v is equal to final velocity, u is equal to initial velocity. We know what is t, time. Okay, now for example, let's say a body, the initial velocity, obviously if a body is about to move from the rest position, at rest position its velocity will be 0 meters per second. That means initial velocity will be 0 meters per second. And let's say its velocity for traveling 5 seconds at b is, we already learn how to calculate velocity, that is to distance by time or displacement by time. So here if its velocity is v is equal to 10 meters per second, it means this is the final velocity. We are calculating the acceleration between these 2 points. Okay, now how we will calculate? Acceleration is equal to final velocity, that is 10 minus 0 by 5 seconds, that is 2 meters per second square. Here the most important part is this. See here, this is velocity, initial velocity and final velocity, and we know acceleration is change of velocity with respect to time. Per second we have to perform, this is for 5 seconds, but generally we will see this is just an example. 5 seconds, you can take 10 seconds, 20 seconds, whatever maybe, but generally we will calculate everything per second. So here the units will be here meters per second by second, so then it will be meters per second square, or meter second minus 2, whatever it will be. So like here acceleration is 2 meters per second square in this problem. Okay, this is how we can calculate acceleration. Now we will see the types of acceleration. See, there are two types of acceleration: uniform acceleration and non-uniform acceleration. You already learned what is acceleration. By the term you can easily guess, that is, if the acceleration is in uniform way or constant, then it is called uniform acceleration, and it is opposite is non-uniform acceleration. If it is not uniform, then it is non-uniform acceleration. We will see one example for each. Here we will see the same example. Okay, here the initial velocity 0 meters per second, and here is 10 meters per second, and here it is 20 meters per second, and here it is 30 meters per second. Okay, here if you want to calculate acceleration, we know it is final velocity minus initial velocity by t. There is final velocity is 10 and initial velocity is 0. If the time taken is same, you take 2 seconds, it is 5 meters per second square. We know here velocity units are meters per second and acceleration units will be meters per second square, because we are telling per second, acceleration per second, change in velocity per second per time. So usually we'll denote per time means second. So in again another, in these 2 points, the final velocity minus initial velocity by time, again it is 5 meters per second, and again calculate this, again it will come as 5 meters per second square. See here, you can see the acceleration is uniform, change in velocity is uniform, so we can say it is uniform acceleration. And for non-uniform acceleration, see, if you started at your home, that is means you are at rest position, and for first 2 seconds your velocity is 10 meters per second, and another 2 seconds, if suppose there is traffic, so your velocity is 12 meters per second when you reach the third point, and after that there is a freeway, means there is no traffic, so there the velocity is 20 meters per second. You calculate acceleration, obviously it will be 5 meters per second square for first, and for second it will be 1 meters per second square for second 2 seconds. Next 2 seconds the time is same obviously, so next 2 seconds it will be 4 meters per second square. See here, the no constant or uniform, you can say. That means it is not uniform, so it is non-uniform acceleration. The change in velocity is not uniform, it is changing, so it is non-uniform acceleration. So this is called acceleration and types of acceleration. I hope you have learned something from this video. Thank you.